Hello and welcome to another geometry lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 1, Lesson 5 on pairs of angles. We've been spending a lot of time on the angles lately. First we introduced them, the idea that they're simply a collection of two rays that have a common starting point, a common vertex. Then in our previous lesson, we learned how to classify angles by how big they are, right? Acute angles being these sharp angles between 0 and 90, right angles being 90-degree angles, obtuse angles being between 90 and 180, etc. Well, we'll also start in today's lesson looking at pairs of angles that are somehow related to one another. So let's get right in there. You may want just a kind of a handheld calculator. Hopefully we'll get in there. There we go. I have my Texas Instruments scientific calculator, my 30XS something or another, that I'll be bringing out when I need to do some arithmetic that I don't want to do in my head. All right, and you may want to have a little calculator handy as well. All right, so let's get into them, right? We've got pairs of angles, and of course, every type of pair has a name. Otherwise, how would we keep them straight? So there are many angles that pair up in ways that express important relationships between their locations or their measures, okay? So it could be just sort of where they're located or what their measures are. So let's begin with one that is extremely important, what are known as adjacent angles. Two angles are called adjacent if they are one, non-overlapping, and two, have a ray in common. Okay, now the word adjacent in math is very important, as it is in real life. Adjacent means next to. So adjacent angles are sort of two angles that sit next to each other that share a common ray and don't overlap at all. Let's work with that idea in exercise number 1. Given the diagram shown below, answer the following question. A, name a pair of adjacent angles and state their common ray. All right, this is simple enough, right? Again, adjacent angles are non-overlapping angles. We'll talk about what that means in a second, that share a common ray. So in this case, what I've got is I've got angle LKM and angle MKN, right? Those two angles, the one that goes from here to here and the one that goes from here to here, they are adjacent. So angle LKM and angle MKN. Those are adjacent angles, angles that sit next to each other, and their common ray is ray KM, right? So it says state their common ray, that's ray KM, right? You can actually see it in the names of the angles themselves, right? Here's KM here, and here's KM there, right? Now, let's take a look at angles that share a ray but aren't adjacent. Letter B. Name a pair of overlapping angles that share a common ray. State their common ray. All right, so let me erase this. Now, there's a couple choices here. But since there's only 3 angles in the picture, and there really are only 3, right? There's LKM, MKN, and then there's LKN. LKN's got to be one of them, right? So angle LKN, right? This entire angle, right? Well, that angle overlaps. Let's go with angle LKM, right? These two angles overlap, right? That's what it means for adjacent angles to not overlap. Here's a case where two angles overlap. Now, they do share a common ray, and that common ray, whoops, almost made a mistake there. Always have to state the ray by the starting point first, and their common ray is KL. Now, don't get me wrong, you could also do LKN and MKN, in which case KN would be the common ray. Now, by the way, angles can overlap, right, and not share a common ray at all. So before we kind of move on to letter C, you could imagine a situation where you had something like this, right, this angle, and then you had, let's say, this angle, right? Those are definitely not adjacent, not because they don't share a common ray, right? Although that's one reason that they're not adjacent. But the other reason they wouldn't be adjacent is because they overlap right in here, right? They overlap right in there. Anyhow, let's get rid of that and let's take a look at letter C. If the measure of angle NKM is 102 degrees, and the measure of angle MKL is 6x minus 10, and the measure of angle NKL is 4x plus 24, then find the value of x. So here we come back to another one of these algebra problems that's basically just based on geometry. It's not really a geometry problem. The first step of it is, but after that, it's all algebra. So I'd like you to pause the video now and see if you can set up an equation based on all of this information and the diagram and your knowledge about how adjacent angles relate to one another. All right, well, let's label what we know, right? NKM, that's this angle right here, and that's 102. MKL, that's the angle right here, that's 6x minus 10. And NKL, that's this thing, that's 14x plus 24. Well, the whole point of adjacent angles is the idea that I can now take the 102, add it to the 6x minus 10, and get the measure of the whole angle, 14x plus 24. So in other words, I can take 102, add it to 6x minus 10, and get 14x plus 24. Once I've written down that equation, the geometry is over. This is now just algebra. That's all it is. So, yeah, let's do a little bit of algebra, right? Not much we can do on the left-hand side, although we can take the negative 10 and the 102 and combine them to get 92. On this side, we have 14x plus 24. Here's a situation where we've got variables on both sides of the equation. So I think I'll subtract, a 6x from both sides and have an amazingly bad looking line there. So now I have a 14x. And again, this is where having just a calculator handy, so you can just do something like 92 minus 24. Very quickly, I'll get 6x plus 68. Now I can subtract a 6x from both sides, right? And I'll get 68 is equal to 8x. And extend the page a little bit, divide both sides by 8. This is where I really like having the calculator, 68 divided by 8. And I get x equals 8.5. If everything's a nice whole number, not so bad, but when the decimals come out to play, it's nice to have the calculator there. All right, but again, I really want to emphasize something about this problem and many problems that we see in this class. Many of them are going to be sort of algebra problems hidden under the guise of being a geometry problem. But once you recognize that this angle plus this angle is equal to this angle, and you write down an equation based on that, the geometry is over. Now you're just doing algebra. All right, let's take a look at some more pairs of angles, complements and supplements. My oh my. Because of how important right angles and straight angles are in geometry, when two angles sum to either 90 degrees or 180 degrees, we give the angle pairs special names, okay? So here we go, complementary and supplementary angle pairs. Complementary angles. Two angles are called complementary or complements of one another if their measures add up to 90 degrees. When placed adjacent to each other, they would form a right angle. Supplementary angles, or two angles, are called supplementary or supplements of one another if their measures add up to 180 degrees. When placed adjacent to each other, they would form a straight angle. Awesome. Okay, so just very important. Complementary angles add to 90, supplementary angles add to 180, and you gotta memorize these terms. It is what it is, okay? So let's take a look in exercise number 2, see what it asks us to do. Find the measure of angle BAC shown below. Then, using your protractor, construct angle D, which is complementary to angle BAC, and angle E, which is supplementary to angle BAC. Mark the measure of each on its diagram. All right, we'll take a moment and just figure out the measure of angle BAC, and then we'll take it from there together. All right, simple enough. Let's take a look at what this measure is. I bring my compass over, put its center point on A, and the measure of angle BAC is equal to 30 degrees. All right, so we got a nice 30-degree angle there, real simple. Now, I want to construct angle D, which is complementary to angle BAC. Well, the first thing I'm going to do is I'm just going to draw myself a little ray, maybe right up here, just to kind of give myself something to work with. All right, now, what does it mean to be complementary to an angle that's 30 degrees? Well, for something to be complementary to BAC, it has to add to 90 degrees, must sum to 90, and so hopefully it's obvious that it has to be 90 minus 30 or 60 degrees. 60 degrees. So, in other words, I can take my angle up here, I can kind of mark a little 60 on my diagram, move that out of the way, bring this up. Whoops, that was supposed to rotate it. It did not. There it goes. And this now, oops. What is that? That's angle D, and that's 60 degrees. All right. And again, the cool thing is if I took this angle and I put them adjacent to one another, they would form a 90-degree angle. Now, for my supplementary angle, right, which means adds to 180 degrees, again, it's simple enough. I can think, well, what is 180 minus 30? And that'll be 150 degrees. Same idea. Okay, maybe I'll come in here and rotate this down so that I start with a horizontal ray. All right, there we go. Bring in my protractor. Find the 150 degree mark on it, which is right there. Oh, hello. That's not what I wanted to have happen. And now bring this over and draw my 150 degree angle. And what is that? That's supposed to be angle E, and that's 150 degrees. Again, if I took BAC now and I put it up here, then I'd get a straight angle. All right, so it's simple enough, right? Complementary angles add up to 90 degrees. Supplementary angles add up to 180 degrees. Excellent. Wow, we're all over the place there. Let's take a look at exercise number 3. In the diagram below, points E, F, and I are collinear. Letter A, what does the fact that E, F, and I are collinear tell you about the measure of angle EFI? That's simple enough. Why don't you write something down? All right, now it's critical that we know that points EFI are collinear. If we're not told that, we really can't assume it, even though even really good geometry teachers will sometimes mess up and they'll just have you assume that those lie in a straight line because they look like they lie in a straight line, all right? But the fact that we are told that they're collinear means that this angle, right, the measure of angle EFI must equal 180 degrees, right? That's what them telling me those 3 points are collinear gives to me. All right, let's take a look at letter B. Name 2 pairs of supplementary angles. Now remember, supplementary angles are angles that will add up, their measures will add up to 180 degrees. So this obviously is going to come into play. See if you can name the 2 pairs of supplementary angles in this diagram. All right, well, one pair will be these, right? So angle EFH and angle HFI, right? Whatever those two are, they're adjacent angles, right? That then form this straight angle, so they must be supplementary. But likewise, right, we also have this angle and this angle, those two right angles, right? So that would be angle EFG and angle GFI. Both are supplementary. All right. Now, letter C, though, name one pair of complementary angles. There's only one pair of complementary angles in this diagram. You go ahead and name them. All right. Complementary angles, right? Those things sum to 90 degrees, right? They add up to be a right angle. And there's only one pair of those, two angles that do that here. Those are these two angles, so angle GFH and angle HFI. GFH, right? This guy, that nice little acute angle, and HFI, another acute angle. Okay. Complementary and supplementary. Now, complementary and supplementary also get wrapped up a lot in word problems that then kind of can involve some algebra. So let's take a look at a couple of those. Exercise number 4. It is given that angle A and angle B are complementary. There it is, right? If the measure of B is 15 more than twice the measure of A, determine the measure of both angles algebraically. Ah, man, if this doesn't feel familiar from Algebra 1, I'm not sure what would. Pause the video now, see if you can set up an equation. You may want to start with let statements, but once you've done that, try to set up an equation and solve it to figure out the measure of both angles algebraically. Pause the video now and take a few minutes. All right, well notice the measure of B is based on the measure of A. So in that case, what we often will do is something like this. Let the measure of angle A be equal to x. So then I'm going to let the measure of angle B be equal to twice x plus 15, right? B is 15 more than twice the measure of A, so 2x plus 15. This is still all algebra all the time. In fact, the only geometry is going to come in right here. A and B are complementary. That means that the measure of angle A plus the measure of angle B is equal to 90. This is where it's key to know that complementary means 90, supplementary means 180. So I'll get x plus 2x plus 15 is equal to 90. That's 3x plus 15 is equal to 90. That means my 3x must be equal to 85. Time for the TI Smart View, where I'm going to just do 85 divided by 3. That doesn't seem right. No, not 85, 75. Because a 15 became a 5 somehow. That's a 75. Now I don't even need my calculator. Divide both sides by 3, and I get x equals 25. Fantastic. Great. So I want to determine the measure of both angles algebraically. We know the measure of angle A now. That's going to be 25 degrees. And we can figure out the measure of angle B, which is going to be 2 times 25 degrees, which is 50 degrees, plus 65, which is 65 degrees. So we've got 65 and 25 degrees. And one of the great checks on it, right, is that I know that the two angles are complementary, right? So I know that the two angles have to add up to 90 degrees. 65 degrees plus 25 degrees is equal to 90. So I'm pretty confident that I have it right, even after the little snafu down here where somehow a 15 became a 5. Ever have that happen to you? From one line to another in an algebra problem, just something gets missed. All right, let's take a look at exercise number 5. It is given that the measure of angle BAE is 4x plus 11, and the measure of angle QRP is 6x minus 1. If BAP and QRP are supplementary, determine how many degrees larger is the measure of angle QRP than the measure of angle BAE. All right, well, go ahead and play around with this problem. See what you get. All right, Well, simple enough, maybe even easier than the last problem, right? We know that they're supplementary, which means that when we add the measure of angle BAE to the measure of angle QRP, right, then we're going to get 180 degrees. All right. They've already told us what these things are algebraically: 4x plus 11 and 6x minus 1. Right? So we'll get 180 there. Now we can combine some like terms. That's 10x plus 10 is equal to 180. Hopefully now I can do my algebra right. Subtract 10 from both sides. I'm going to get 10x is equal to 170. Divide both sides by 10, and I'm going to get x equals 17. Great. But now keep in mind, we want to know how much larger QRP is than BAE. So the first thing I need to do is actually figure out how big both those angles are. So let's figure out the measure of angle QRP. That's going to be 6 times 17 minus 1. Clear. 6 times 17. Enter. Minus 1. Enter. All right, that's going to be 101 degrees. That's the measure of angle QRP. Now the measure of angle, BAE is going to be 4 times 17 minus 1. So we'll do 4 times 17 minus, not minus 1, plus 11. Boy, I tell you, 4 times 17 plus 11. So we'll just do 68. 68 plus 11. Here we go, 79. Before we finish this problem, right, real quick check. QRP is 101. BAE is 79. If I add 101 plus 79, I get 180. Cool beans, that's what I need, right? I need them to add up to 180. But still, the problem is how many degrees larger is one than the other? So that's 101 minus 79, and that gives me 22 degrees larger. As my final answer. All right, that's it, right? Complementary and supplementary. But we need to know that terminology, because if we don't, there's no way to even begin these problems. Let's take a look at one last one. Exercise number 6. In the diagram below, line RT and line UV intersect at point S. Letter A, name 2 angles that are both supplementary to angle UST. All right, so I claim that there's 2 angles in this diagram that are both supplementary to angle UST. See if you can name them. All right, well remember, supplementary angles are angles that add up to 180 and that when put together will form a straight angle. So one angle that's supplementary to this is going to be angle RSU. RSU. All right, actually, let me call them USR to be consistent. Oh, that was beautiful. Wow. There we go. Angle USR, right, which is that, and angle TSV, right? This forms a straight angle, and this forms a straight angle, because that's not confusing at all. Okay. So both of those angles that I mentioned in problem B are supplementary to angle UST. Now let's take a look at letter B. If the measure of angle UST is 130, then find the measure of angle USR and the measure of angle TSV. So again, I actually now want to find the measure of both of these 2 angles if I know that the measure of UST is 130. Why don't you pause the video and go ahead and do this. All right, well, we know that 2 angles that are supplementary will add up to 180. So if I know that if I know that UST is 130 and USR and UST are supplementary, then the measure of angle the measure of angle USR must be 180 minus 130, which is 50 degrees. Likewise, right, the measure of angle TSV must also be 180 minus 130, must also be 50 degrees. Right, and it kind of makes sense, right? Up on the diagram, this is 130 degrees, right? And if I want this angle, well, that angle, USR, must be 50 degrees in order to make this whole thing 180. But likewise, angle TSV, which is down here, also has to be 50 degrees in order to make this entire angle a straight angle, or 180. So, our final little piece of the lesson, let's take a look at letter C. What do you think is true about angles that are supplementary to the same angle? Well, what do you think? What could you write down? Pause the video now. Well, two angles that are supplementary to the same angle must have equal measures, right? They must have equal measures. And if you just said that the two angles must be equal, that's fine. You know, some people might quibble with you a little bit and say, well, an angle can't be equal to another angle because it's like saying a house is equal to a house. You know, it's not a number, so it can't be equal. But whatever, they have equal measures. And this makes sense, right? If I have some random angle over here, you know, something 100 degrees, and I say, oh, this angle is supplementary to it, well, it's got to be 80. And I've said, well, this other angle is supplementary to it, well, it would also have to be 80. So we kind of summarize this by saying supplements of equal angles are equal. Right? Supplements of equal angles are equal, or supplements of the same angle are equal. And that's going to be very important as we move forward in geometry. All right, let's do a little summary. So today we saw certain pairs of angles, and we'll see more of them in future lessons. And what did we see today? Not very much. We saw adjacent angles, two angles that sort of sit next to each other. They don't overlap, but they do share a common ray, right? Then we have these things called complementary angles and supplementary angles. Complementary angles, very important because they add up to 90 degrees. And supplementary angles, also very important because they add up to 180 degrees. And given how important right angles and straight angles are, complements and supplements are huge in geometry. All right, well, I'd like to thank you for joining me for another geometry lesson by eMath Instruction. We're not doing algebra anymore, although it sometimes feels that way. All right, until I see you again, right? My name is Kirk Weiler. Keep thinking and keep solving problems.